Okay, so we're gonna deal with and talk about SDN um, from a Microsoft data center standpoint, right? And whether the data center is AWS or Azure or GCP, we're still going to be utilizing the same, like for network controllers, we'll still be utilizing REST APIs. We'll still be managing things in a very similar way because even though there are different flavors of cloud data center technologies, we're still basically doing the same thing, just in a different way. So let's talk about, let's bring this up. We're going to talk about some of the scenarios and the requirements for implementing SDN. We're going to talk about different scenarios, some of the requirements for a Hyper-V network virtualization. We've got a whole new bunch of acronyms that we need to get familiar with now. So HNV is Hyper-V network virtualization. And NVGRE, which is generic root encapsulation, is something in Cisco we do at like a CCNP level. So here we're talking about virtualized generic root encapsulation. And we're going to be talking about XVLANs. And XVLANs are the VLAN management for our extensible cloud resources. So we're quite familiar with VLANs. Well, we've got XVLANs now. We're going to talk about software load balancers and different scenarios for Windows Server gateways and policies for firewalls. So we've got a System Center virtual machine manager. So one of the most critical parts of the Microsoft Cloud system is System Center Virtual Machine Manager, and it enables centralized management of our virtualized workload. It's the component where mostly everything comes together in some way, from the fabric resources like storage and compute and networking up to virtual machines and the services running on top of the fabric layer. So our Virtual Machine Manager basically allows you to pool resources and offer them to tenants that can then deploy resources and virtual machines to those pools. So this means that the Virtual Machine Manager not only manages not only your virtual machines, but it also manages your network environment, your storage, and a whole lot more. So it basically allows you to manage the virtualized data center infrastructure, increase server utilization, physical server utilization by providing simple and fast consolidation of virtual infrastructure, perform virtual to virtual migration, which is V2V, and perform intelligent workplace placement based on performance data and user-defined business policies. With Virtual Machine Manager, a cloud is an on-premise logical grouping of resources like storage, network hosts, load balancers, and libraries. So we've got our Virtual Machine Management server, and here's an example of our SC VMM. And we also have our libraries. So we've got the library is the catalog of resources that can be used to deploy our virtual machines and services. It includes our hard disks, our iOS images, our templates, our profiles, our PowerShell scripts, our answer files, and our virtual machines. The Virtual Machine Management Administrator console basically just lets you view and manage all of the server and related components. So that includes our physical and our virtual resources. And so another thing that we've got is PowerShell. Yay. So VMM also includes PowerShell via, and that allows you to run commands and perform all the functions that you can perform within the VMM administrator console. In a data center environment, we're kind of managing our resources according to our customers' needs. So sole tenant nodes enable a number of valuable use cases. Compliance and regulation. So organizations with strict compliance and regulatory requirements can use sole tenant nodes with virtual machine placement to facilitate physical separation of their compute resources in the cloud. It also allows isolation and utilization. So you can control instance placement directly using user-defined labels. So basically, it allows you to shape your nodes in order to achieve the highest level of utilization. So when we're looking at this diagram, we're really looking at multi-tenant would be, we have multiple customers utilizing virtual machines on one physical data center server, right? One VMware host, Hyper-V host machine. Whereas single tenant means that one customer is utilizing the entire box, the entire physical server, or the entire host. So software-defined networking. So when you're creating a virtual infrastructure, you're going to configure our Hyper-V virtual switches and Hyper-V network virtualization and our Windows Server Gateway. You're going to need to use and manage our physical switches, routers, and other hardware devices, and integrate those virtual devices and physical devices together. So SDN allows us to incorporate all of those features. Some of the components that are really relevant would be our System Center Operations Manager, and that's going to provide the infrastructure monitoring for your data center, both for your public and your private cloud. We've got our System Center Virtual Machine Manager, which gives you the tools to manage a virtual infrastructure, and it gives you the ability to provision and manage virtual networks. And then we've got our Windows Server Gateway, and that allows you to route your data center and your cloud traffic in between your virtual and physical worlds. The Windows Server Gateway is a virtual software router and gateway. So using SDN bypasses some of the limitations that are imposed by the physical network, and it implements a software abstraction layer that enables you to manage your network dynamically. When you're using SDN, you can implement a cloud-based network infrastructure and overcome the limitations of your on-prem devices. It offers a number of benefits. It's really efficient. Your hardware, you can abstract hardware components in your network infrastructure by using software components. It's flexible. You can shift traffic from your on-prem infrastructure to your public or private cloud infrastructure. It's scalable. You can extend as needed into the cloud and provide far broader limits than your on-prem infrastructure can support. You can virtualize your network and break the direct connection between the underlying physical network and the apps and virtual servers that run on it. You must virtualize your network management by creating virtual abstractions for physical network elements, including ports, switches, and even IP addresses. We can define policies. So you can define these policies in your network management system and apply them at the physical layer, enabling you to manage our traffic flow across both the physical and the virtual networks. And it just allows you to manage the virtualized network infrastructure. It gives you all the tools that you need to configure your virtual network objects and policies. So it's pretty cool. And once you kind of wrap your head around it, certainly we can understand that. So we've got, so some of the components that we have, of course, is our Hyper-V network virtualization. So our HNV. That enables you to abstract the underlying physical network from your apps and workloads with virtual networks. We've got our Hyper-V virtual switch, and that enables you to connect virtual machines to both virtual networks and physical networks. We've got our routing and remote access multi-tenant gateway, and that allows you to extend the network boundaries to the cloud so you can deliver an on-demand hybrid network infrastructure. We've got NIC teaming, so you can configure multiple network adapters as a team for bandwidth distribution and for failover, and our network controller. And that was a new feature in Server 2016, and it provides centralized management for both the physical and the virtual networks. So if we were looking at Cisco, our network controller would be Cisco DNA, right? So there's a lot of similarities here, and it's good for you to understand that they're all pretty much doing the same thing in different ways. With SDN Integrate, you can integrate SDN with Microsoft System Center to extend your SDN. So your System Center Operations Manager enables you to monitor your infrastructure, and the Virtual Machine Manager enables you to provision and manage your virtual networks, provide centralized management for your network policies, and of course, once again, your gateway is a virtual software router and gateway that can route traffic between your physical and your virtual networks. Am I talking too fast? So some of the prerequisites, you need to determine your deployment scenarios and your network requirements for deploying SDN. And before you can deploy it, you have to make sure that your network infrastructure meets some of these requirements. And they kind of fall into two broad categories. We've got the physical network. So you have to be able to access all of your physical networking devices and components. That includes your VLANs, your routers, your border gateway protocol devices, DCB with enhanced transmission selection if you're using RDMA technology, and DCB with priority-based flow control if you're using RDMA technology that's based in RDMA over converged Ethernet. It's just a mouthful, isn't it? We also have to consider our physical compute hosts, right? So we have to make sure that our infrastructure and tenant virtual machines, we've got Windows Server 2016 installed or 2019 installed, that we have the Hyper-V role enabled, of course, that we have external Hyper-V virtual switch created with at least one physical adapter, and we have to be it has to be reachable with a management IP interface assigned to the management host virtual NIC. So doesn't this look great? After you've verified that your infrastructure meets the requirements, then you can start planning your deployment. And this picture kind of, shows us how we've got two different tenants. We've got tenant 1 and tenant 2, and how they are utilizing one server, one physical server that is a host provider for both of the tenants. And we've got our management network interface, and we've got our physical switch subnets and our VLAN trunk. So let's sort of, dive into that. So we've got our management and Hyper-V network provider logical networks. So our physical compute hosts have to have access to the management local network and the HNV provider logical network. So each physical compute host has to be assigned at least one IP address from the management logical network, and you can assign a static IP address or you can use DHCP. For our logical networks for gateways and the software load balancer, you have to create and provision logical networks for the gateway and and software load usage. For transit, I'm used by the SLB software load balancer multiplexer, and remote access gateway and exchange for border gateway protocol peering information for our north-south, so that's external and internal tenant traffic. We've got our virtual IP addresses. We have to have an IP subnet prefixes that are internet routable outside of the cloud environment, and that are front-end IP addresses that external clients can use to access your virtual networks. We've got a private VIP, our virtual IP address. It doesn't need to be routable outside of the cloud. It's used for VIPs that are only accessed from internal cloud clients like GRE gateways. We're going to have a GRE virtual IP address used to define our VIPs that are assigned to gateway virtual machines running on your SDN traffic, your SDN fabric for our server-to-server GRE connection type. So that would be our horizontal east-west connections. We're going to have logical networks requiring our RDMA base storage. And with that, you're going to define a VLAN and a subnet for each physical adapter on your compute and storage host if you're using RDMA-based storage. For routing infrastructure, that information for the VIP subnet is advertised to the physical network using internal BGP peering. And so you'll need to create a BGP peer on the router that your SDN infrastructure uses to receive routes for the virtual IP logical networks advertised by your software load balancing multiplexer and the HNV gateways. For a default gateway, yay, something that we're familiar with, right? You have to configure only one default gateway on the physical compute hosts and the gateway virtual machines. And this is usually the default gateway on the adapter that's used to connect to the internet. And of course, then we've got our network hardware, and your network hardware has to have a number of requirements, including those for network interface cards, switches, link control, availability, redundancy, and monitoring. So lots of things that you need to consider when you're managing this kind of thing. And here's an example of a scenario. You can use network virtualization to manage our network traffic by creating multiple virtual networks, logically isolated on the same physical network. So here we've got our server virtualization and our Hyper-V network virtualization. So we're running those on our physical network, but it's virtual. Oh, and if we go back to that, we can see that we've got two different networks in there. We've got the Contoso network and the Fabricam network. Each of those is a different tenant, and they're still utilized on the same machines. So if you have people on one network, so if you have those networks divided up between those two physical servers, they can communicate with each other just because they're on their own VLAN. So that's one way of looking at that. So things that we need to think about. So one of the nice things is that we've got compatibility. So the network virtualization avoids the need to redesign your physical network to implement network virtualization. We've got flexible IP address use, so we can isolate virtual networks, enabling IP address reuse. Your virtual machines in different virtual networks can use the same IP address space. So if you have one, in other words, if you have one Hyper-V host and you have two companies that are leasing space off of that one Hyper-V host, and they have their own VMs, they have their own separate networks, they can use the same IP addresses because they're going to be on different VLANs that are completely separate. And when you're playing with, your Hyper-V host scenario, you can change your VLANs. So you could set up two different VLANs because we always set the same VLAN ID, right? You can change the VLAN ID. And then you can have two separate networks operating in that same environment. So we've also have flexible virtual machine placement. So we could separate the IP addresses to enable virtual machines from the IP addresses used in your physical network. And then that allows you to deploy your virtual machines on any Hyper-V host. And it doesn't matter about the physical constraints. We can have network isolation without VLANs, and that allows you to define network traffic isolation without requiring VLANs or needing to reconfigure your physical network switches. And we could have inter-subnet live migration, and that lets you move your virtual machines between two Hyper-V hosts in different subnets using live migration without having to change the virtual machine IP address. So kind of a short and simple one. We've got flexible virtual machine placement. We've got multi-tenant network isolation without VLANs. We've got IP address reuse. We've got live migration across subnets. It supports running virtual machines on a shared infrastructure as a service, so a cloud. We'd also have support for resource metering, and we can configure it all by using PowerShell. Yay! So our Hyper-V switch supports network virtualization, and you can either use network virtualization. You can either use NVGRE, or you can use VXLAN. So VXLAN is virtual extensible LAN, and that uses VLAN-like encapsulation techniques to encapsulate our MAC-based OSI layer 2 Ethernet frames within our layer 4 UDP packets. By default, it's going to be using UDP port 4789. Our VXLAN endpoints, which terminate VXLAN tunnels, could be either virtual or physical switch ports, and they're known as VXLAN tunnel endpoints, or VTEPS. And I think wrapping our head around all of these new acronyms and understanding where they fit in the structure really helps in our overall understanding. So here we're implementing HNV with NVGRE encapsulation. So if you're doing it with NVGRE, NVGRE is used to encapsulate the packets, and to configure, you first start by associating each virtual network adapter with 2 IP addresses. So the customer address, so that's our CA. And as you can see on this diagram, we've got 2 different companies, right? We've got a company that's blue and a company that's red. And so one of our customer addresses, so one of our customers is blue and the other one is red. But you can see they're both using the same IP addresses, right? Which is kind of interesting. If you look at the CA on there, it's using the same IP addresses. The CA is used by the virtual machine and configured on the virtual machine adapter in the virtual machine guest operating system. The PA is our provider address, and that's assigned by HNV and used by the Hyper-V host. So you can see that each Hyper-V host is assigned one PA address. So we've got host 1, which is 192.168.110 for our PA address on host 1. And in host 2, we've got 192.168.220. So these PAs are used for tunneling the NVGRE traffic between the physical networks, and that would be the 192.168.1 and 192.168.2 dot networks. And this tunneling is occurring on the physical network. Each virtual machine is assigned a CA address. So here we've got 10.1.1.11 or 10.1.1.12. And these addresses are unique on each virtualized network, and the traffic between is tunneled using NVGRE tunnels between the hosts. And to ensure the separation of the traffic between the 2 virtualized networks, a GRE key is included in the GRE headers on the tunnel packets, and that provides a unique virtual subnet ID. So in this case, we're using 5001 or 6001 for our GRE key for each virtualized network. So you have 2 virtualized networks, red and blue, isolated from each other as separate IP networks, but extended across 2 physical Hyper-V hosts, each of which is located on a different physical subnet. Are we having fun yet? So setting it up. So to set it up, you can either use System Center VMM, or you can use Windows PowerShell to complete these tasks, but you're basically going to define PAs for each Hyper-V host. You're going to define the CAs for each virtual machine, and then you're going to configure your subnets and configure your virtual subnet IDs for each subnet. So here's how you can do it in PowerShell. First, you're going to enable it. You're going to enable binding. You're going to set up a subnet locator and route records for each host. And this is one of the uglier PowerShell scripts for sure. Then you're going to configure the PA and route records on host 1 and then on host 2. And then you're going to set the subnet IDs on the virtual switches for each VM on each virtual host. And then you're going to repeat the whole process again for the red network, your other tenant. So yeah, it's quite extensive. VXLAN is the default. So instead of using your NVGRE configuration, you can use VXLAN, and that's the default. And in Windows Server 2016, you have to deploy the network controller feature in order to implement VXLAN for HNV. And it's going to be using port 4789 as its network transport. So here, when we're looking at this, we're deploying our network controller, and with the network controller, which is a new feature in Server 2016, you can manage and configure both your physical and your virtual network infrastructure. You can automate the configuration of your network infrastructure. You can use network controller to manage your Hyper-V virtual machines and virtual switches and your data center firewall and your RAS multi-tenant gateways, virtual gateways, gateway pools, and your load balancers. So you can do all that using your network controller. And of course, you have to install the role. So that would be the network controller role. You can deploy network controller in both Active Directory domain services, domain and non-domain environments. So if you deploy it in a domain environment, your network controller is going to authenticate the users and the devices using Kerberos. If you deploy in a non-domain environment, you're going to have to deploy digital certificates to provide for authentication. So after you've deployed and configured your network controller, then you can use it to configure and manage both your virtual and your physical network devices and services. So like some of those would be like software load balancing, or your RAS gateway management, your firewall management, your virtual network management of your Hyper-V switches, and your virtual network adapters on individual VMs. And don't forget your network policies, right? So we've got network programming APIs, right? And so there's a couple of things that are pretty standard. You know, it doesn't matter which vendor you're using. You know, when we're talking about northbound and southbound, southbound is used to communicate with the network. Northbound gives you the ability to communicate with the network controller. So northbound is going to let you collect network information from the network controller, and then you can manage and monitor and configure your network. Your northbound API is going to let you configure, monitor, troubleshoot, and deploy new devices on the network by using PowerShell or REST API, System Center, or third-party tools. Southbound network controller is going to use the southbound API to communicate with the network devices, services, and components. And with a southbound API, network controller can discover devices and configurations, collect statistics, and send change information. So software load balancing. So here we're talking east-west load balancing. So east-west load balancing is your VMs talking to each other. If you have large networks, you can try and divide the workload by distributing our network traffic among virtual network resources. So like network load balancing, Windows Server software load balancing enables multiple servers to host the same workload, and that provides some high availability and some scalability. So you can have increased throughput and disaster maintenance. So when you're looking at it, you can divide it into two traffics. North-south is between servers and clients. East-west is just between the servers. And software load balancing can be used for both types of traffic. So here is our SLB infrastructure. SLB provides layer 4 load balancing for both north-south and east-west TCP and UDP traffic. We've got public and internal network traffic load balancing. We've got support for dynamic IP addresses, or DIPs, on Hyper-V virtual networks and VLANs. We've got support for health probes. We can map our virtual IP addresses, so our VIPs, to our DIPs. So for example, VIPs are single IP addresses that map to a pool of available virtual machines. They're IP addresses available on the internet for tenants and tenant customers to connect to tenant resources in the cloud. And DIPs are assigned to tenant resources within your cloud infrastructure and are the IP addresses of the virtual machines that are members of a load balance pool. So we're going to need a Windows Server Gateway, right? And that's a virtual machine-based software router and gateway. And that allows our cloud service providers and enterprise organizations to enable data center and cloud network traffic routing between our physical and our virtual networks. And that includes the internet, of course. And we've got a data center firewall, and when the data center firewall is deployed, our tenant administrators can install and configure firewall policies to help protect their virtual networks from unwanted traffic and internet and intranet networks and between tenants. So it's a stateful firewall, and it looks at the state of the current connections and allows inbound connections based on the outbound response for a connection. So a stateful firewall is going to wait for an initiation first. We've got the distributed firewall manager, which is part of the network controller. And with that, we can have ACLs that are applied to a virtual subnet or a network interface. And we've got our network security groups, and they contain access control list rules that either allow or deny traffic to or from a virtual subnet or virtual machine. And yeah, so we really kind of went through a lot, but this kind of gives you the Microsoft perspective of SDN and how they manage their cloud resources. So SDN, of course, allows you to, basically manage and configure your physical and your virtual network devices. And it can extend your network. It's how you're going to be managing your cloud resources. We've got our APIs. We've got northbound and southbound APIs. The southbound API communicates with the network, and the northbound API communicates with your network controller. And then we've got our east-west traffic, and that's the server-to-server traffic, right? So we've got software load balancing to distribute our network traffic, and it's pretty much just like network load balancing, except it's software-based. It's going to provide high availability and scalability. And of course, we need a gateway, which is a VM-based software router, so that we can move our resources around and access them. We've got a network controller data center firewall. That's a stateful firewall, and that can control both east-west and north-south traffic. And it's stateful and multi-tenant. So if we have two companies utilizing the same two tenants that are hosted on one virtual machine host, they can set up the firewall separately. So they can do it according to their needs and set up their policies according to their virtual networks. And that's the story of SDN.